Welcome everyone. Thank you for coming this afternoon. I hope you all had a good lunch and a good ice cream treat. This session is called Getting Started with Web Development and the ArcGIS API for JavaScript. So my name is Noah Sager. I'm a product engineer on the JavaScript team, and I'm here with...
Hey everybody, my name is Heather Gonzago. Product engineer with the JavaScript API team as well.
All right, excellent. And before we begin, if we could have a quick show of hands, how many people here have done web development before with JavaScript? All right, so almost everyone, excellent. And how many of those same people have already worked with the ArcGIS API for JavaScript? Okay, a fair number of you. How many of those people have worked with the 3.x version of the API? Okay, excellent. And the 4.x version? Okay, a couple hands, excellent. So this is going to be a good course for everyone. Basically, we're going to cover, I'll go to the agenda. So first, we're going to cover the setup, both in terms of working with web development and in terms of working with the ArcGIS API for JavaScript. And then we're going to do something kind of cool. Rather than just show you the documentation and show you code snippets, we're actually going to build an entire application from scratch. So we'll slowly add levels of complexity, like different layers, different renderers, make it a bit interactive, and then we're going to end it with some widgets. So I hope you all enjoy. All right, and then a quick bit of housekeeping. This presentation is going to be available on GitHub under Heather Gonzago's repository. If you want to take a quick picture of the link, or you can come talk to us afterwards and we can share it with you. This repository does have her presentations from past dev summits, so if you are interested in 3.x and you want a refresher, you can see her presentations on the 3.x version, as well as this presentation, and all the demos will be available on GitHub. Actually, they're available right now, but you can check them out afterwards. All right. Okay, so the first question, where do I begin? So the main landing page is developers.arcgis.com/JavaScript. And if you're coming from the 3.x world, you'll notice that the 4.x documentation has been completely redesigned. So not only is the API completely new, but the SDK, being the documentation, the sample code, is also completely new. There's a couple sections that I want to highlight here. Is that echo bothering anybody? Okay, maybe it's just in my ears.
No, I hear it too.
Okay.
It's not just you, it's up here, yeah.
So the first thing I want to talk about is the guide. What's really cool about the guide is that it's a conceptual guide that's written in plain English. So it highlights all the concepts. So if you're looking for things like the release notes or the system requirements, it lists that all out here in black and white. If you're working with other APIs, if you work with the Google Maps API, we do have a help documentation here to guide you through the process of transitioning. And then we have a lot of other really cool concepts like working with properties or promises or arcade. A lot of these are generic to web development, and some of them are specific to the API. If you're into TypeScript, we have a whole guide page there. And then, of course, we have a handy reference section. If you've ever had issues with cores or with proxy pages, you can come down to the guide section and read about all these concepts and try to get the fundamentals of what it means to work with the API. All right, so the next question is, which version of the API is best? So we have a section on that in the guide as well. If you heard me at the beginning, I talked about the 3.x version and the 4.x version. So if that's new to you, the story here is that they're both technically current versions of the API. The current 3.x version is 3.27, and the current 4.x version is 4.10. So if you're starting a project now and you want to know which API you should work with, the best thing to do is come to this guide page and look for the capabilities that you need. So for example, if you need 3D, you're only going to find that in the 4.x version. That's not going to become in the 3.x. However, there's some functionality in 4.x that's not in 4.x that already exists in 3.x. But the idea is that down the road, we're going to stop our development efforts on the 3.x API, and we're only going to progress forward with the 4.x API. So if you have the time to wait, the 4.x version is the future. If you need to do something now that's not available in 4.x, you can still consider 3.x as a viable alternative that will still be around for a long time. And even after we finish development with the 3.x version, it'll still be accessible online. You can still run all your applications. Nothing's actually going to turn off. And of course, there's another guide topic about actually migrating and a functionality matrix. So if you're used to layers in 3.x, you can find what they're called in 4.x. For example, my favorite layer is the ArcGIS Dynamic Map Service layer. It's a bit of a mouthful, but we renamed it 4.x as Map Image Layer. So not only is it a rewrite of the API, but we also gave things a bit classier of a name or a bit more useful. So that documentation is there to help you. All right, developer setup. So one of the cool things about working with JavaScript is that it's a little loosey-goosey. So if you're coming from a different programming language, if you've ever developed for iOS, you know you're kind of limited to Xcode. If you're doing Android, you're kind of limited to that IDE. With JavaScript, you have a lot of options, and there's no real answer about which IDE is best. It all depends on your personal preferences and what you're actually doing. So here's an example of what a lot of the different IDEs are that we use in the team. So we use Sublime, we use Microsoft Visual Studio Code, we use Atom, WebStorm, Brackets. Some of these are paid, some of these are free. Right now, I've been using Visual Studio Code a lot because it works great with projects and it's also free. And it's really easy to integrate with things like GitHub and SourceTree. But there's many different options available to you. Other resources. So I talked a bit about the developer page. We also have a GitHub repository that contains a lot of other really cool resources. So if you're interested in TypeScript, you're going to want to come to this repository and clone it and get all the TypeScript definition files. If you're into things like Bower or you want to work more in depth with OAuth, this is another great repository that gets updated regularly with each release. So these are kind of the extra developer tools and cool things that you can use. So if you go to the Esri repository, it's pretty easy to find the JavaScript resources, and it's also linked to within our documentation. All right, getting the API. So there's 3 different ways to actually work with the API itself. The first is the CDN, the Content Delivery Network version. This is the version of the API that Esri hosts, and we guarantee access to it 24/7. There's the occasional, Amazon outages that you hear about that's going to affect us as well as anyone else, but we guarantee access to it. So all you have to do is reference the API here, and here we're calling the 4.10 version, and then your application will work. Another option you have is using custom builds. So how many people have worked with NPM before? Okay, a fair number of you. So NPM is a node package manager. It handles all these different modules that you can import to make your projects do the thing. And what's cool is you can actually use NPM to build a custom build of the API. Now, why you might want to do that is the API itself has all the functionality that's listed in the API reference. So it has everything. So if you're concerned about, say, the size or loading time of your application, you might want to have a slimmed down version of the API that doesn't have the functionality that you're not going to use. So you can build that custom build using NPM and say, I just want to have a printing application, so I need the print widget, I need a feature layer, I need these modules, and that's all. And so you're going to have a much smaller version of the API. Now it's going to be on you to actually host it. So you're going to want to have a web server that has secure access. And the other caveat is if you want to make changes to your application, say down the road you want to add in a different widget or a different functionality, you're going to have to rebuild it using NPM again. So the idea is that if you're at your final stage of your project, it would probably behoove you to make a custom build. But if you're still tinkering with it, you don't need to worry about making a custom build yet, except for like a proof of concept. The last option is to physically download and host the API. So we work with a lot of secure customers that are working in closed off environments that don't have access to the outside internet, and they want to have the API themselves and host it themselves and care for it and nurture it. And so that's a great option as well. The only thing to worry about there is if we make any updates to the documentation or to the API, you'll have to re-download and re-host it yourself. So if you have exactly what you want, this is a totally good way to go. But for the latest and greatest, the easiest is the CDN. So going along with the API is the CSS, the content styling sheet. So we have a couple of different versions of the CSS. And of course, here we have another guide page about it. The main CSS has the styling for the entire API. So anything that you could possibly need, you'll get with the main CSS. And that's also a very simple call to the CSS file. We have another version of the CSS called view.css. So if you ever looked at our configurable apps or any of our other applications, a lot of them will actually use the view.css because it's smaller. And with the smaller file, you get a slightly faster load time. It doesn't have all the functionality, so you'll want to look at it and make sure that it has the styling that you need. All right, with that, I'm going to turn it over to Heather, and she's going to take you through the first steps of actually building an application.
Awesome. Thank you, Noah. So, you guys see it? Okay, great. So, like we said before, we're basically going to build an app up from scratch. All right, so what you guys, if you've worked with our samples before, you might already be familiar with some of the, with how we have them structured. So if you take a look, let's say, for example, at the, I don't know, intro to map view. You'll notice here that we have everything in one big, long HTML file. That's fine. You can do it this way if you prefer. But probably as your application starts to get larger, you may want to go in and modularize that, break things apart, maybe have separate files for your CSS, separate files for your JavaScript, one for your markup. So in our particular case and for our examples, what we're going to do is I've gone in and created a separate folder specifically for my CSS, one for my JS file, for the JavaScript file, and then my index, my markup, okay? So what we have here is we're just going to go and make the very, very first step. So creating a map. It is a map. It's a very ugly map, but it's a map. So what do we have here? If we take a look at the actual code, and you'll see here that what I have is I'm referencing our main CSS, and I'm also referencing our CDN, the 410 version of our CDN. If you're not sure how to go in and access that or what you need to put in here, the easiest thing to do is if you go to our developer site and directly on the landing page, you'll see the link here. So all you have to do basically is just a copy and a paste. You can have the same thing as well if you go to the 3x version. So if we go back in, we'll see here I'm referencing this main.js file. And what you should see, I mean, there's not a whole lot to it. All I have here is I am requiring the Esri map and the map view. I have a map. I'm setting a base map, which is a gray vector. And if we take a look, you can actually see a listing of all of them within our API reference. I just have it set specifically in this case to gray vector. And then we're going in and we're passing in the view div and then the map. Okay, so the map that I just created here and our view div. All right, the view div is what I created here, this div that I have within my markup, okay? So it knows where the actual map view is going to be placed. All right, so there's not a whole lot to this, kind of, like I said, pretty ugly. One of the things though that I want you guys to take note of is in the API reference, take a look, I'm just gonna type in map. If I go to the map class, at the very top here, we've got the require Esri map and then function map. The Esri map, this is how you know. This is basically what you know, where you go to get the information for what you need to pass in for your require statements. All right, so take note as well. This is case sensitive. I've got myself thrown off more than a few times by putting in lowercase m. And then the function, this is just the argument that you pass in. So this is the preferred alias that we say, that we'd like you to use just map, but you don't have to. You can call this whatever you want, anything. All right, just make it make sense. So take note of the require and the function arguments that you pass in. And there we go. And what we have set up here within our require statement. Another thing, I'm jumping a little bit ahead, but I kind of want to touch on it right now, is when you pass in your require statements and your arguments, so I have my map and my map view, you want to make certain that you have it, that the order in which you specify your arguments matters. Okay, so if you decided, you're in here and you're like, all right, by accident, you're in copying and pasting, changing your code up a little bit, and let's say you flip-flopped it and map view is at the top instead of map. You're not going to get the same function. It's not going to work for you, all right? Because it's basically you're going to be trying to get map view calls, or you're trying to access map view functionality off the map class. And I'll show you in just a moment what I'm referring to here. So I'm going to go back in. Let's close out a few things so I don't get myself too spun around. Okay, so yeah, we've got the map view. I didn't really go into too much detail on that. So we have, for those of you that, that have worked with 3 and then moving to 4, this might be a little bit of a change for you. We have the map, there's a map class, and we still have the map class in 4, but in addition to that, we also have a map view. And if you're working in 3D, the equivalent would be the scene view. So basically, that the main difference is the map, you still have the map, and the map is what you use to go in and specify like your layers, and you pass all of that information in there. But the map view is where you actually go in and tell how you want to render that actual map, okay? So back in 3, I don't know if some of you guys may have tried this before, you could do it, but it was kind of difficult to have more than one map within your application. In 4, it's not that hard. You can use one map and render it with multiple map views or scene views if you're working in that way. So just a little bit different. I did this last year. Do you mind if I ask you again? Because I always like it, and I can't do it justice. I remember one time we talked about this for a while because I was like, I get it, but sometimes it's hard to explain it, and Noah had a really good analogy. So if you don't mind, would you go ahead and explain how you like to do it?
Sure. So the analogy I like to use is this view model paradigm is kind of like if you imagine your backyard is a map, and that's what you want to represent. The window from your house to the backyard is the view, is literally the view of the map. So you could have an upstairs window, you could have a downstairs window, you could have a stained glass window in the garage, and they're all going to look at the same map or at the same backyard, but they're all going to look slightly different. So you could have a 3D view, you could have a 2D view, you could have a view that is zoomed in all the way. But no matter what, if you want to see the backyard, you need to have a view of it. So you always have a map and a view.
Awesome, thank you. Good. All right, so one other thing I wanted to show you here is if we go back into this application, again, this is a little trick that I like to do. You probably don't want to start your application or your map at the full extent. You have your base map here, it's zoomed out to everything. So a little trick that I like to do to get the extent or to zoom into a specific location, set the zoom, set the scale, is if you go in to, and in this case I'm working in Chrome, so I'm opening up my dev tools. You don't have to use Chrome. Every browser has something comparable to this. But basically what I have is I've got a global variable set, a view variable set at the top. And what this does is this allows me to access the view once I run this application. So if I go in here, close this out, try this, make sure I've got everything started back up. I am going to access the view and then get the center, and I can access the latitude off of this. So my center latitude, this is going to tell me where where the center location is of my map. But if I go in, let's go in here and actually we're at 0. Let's just zoom to the US. Awesome. Go back in, try the same thing. You can see now I've got a new latitude location. Let's say I have the same thing. I can do it with longitude. I can grab the longitude. I can grab the zoom. I'm at the second zoom level. All right, so I already have this saved out to make it easier. I'm going to copy this, put this back in my code, and I'm going to set it here within the map view. Save this out, clear my cache, and you guys can see now it goes in and it did not give me that huge full-blown extent. All right, so that's just a little tip, little trick that I like to use a lot of times. I know if, you just don't know that long off the top of your head, right? So that's a good way to get that information. All right, some of the other, which I mentioned a little bit earlier on, was that module order. All right, so remember how I mentioned that the module order really does make a difference. If I go in here and let's say I just change this to map view map, basically what I'm doing now is that I'm saying, hey, I'm creating a map. I'm trying to set this base map off the map, but in reality what it's thinking is I'm actually trying to get the map view because it lines up the arguments with how you have it set. All right, so if I ran this, I'm guessing nothing will happen, meaning nothing will show. Yep. Sometimes you'll get errors, sometimes you won't. This is just that's a hidden error that I've got set up. It doesn't matter in this case. But yeah, sometimes you'll get errors, sometimes you won't. There's no errors in this particular case because there's not a lot of code involved. But a lot of times you'll see things like property not defined. That's the big one. If you guys, any of you guys work in GeoNet, answer questions, play around with it at all? If you really want to become an MVP, this is what, especially for new people, you're going to see this question lots of times. That will be the answer, guaranteed. You'll be the star, the MVP star for answering on those. All right, so that's a big one. The CSS, that's another one as well. So a lot of times, the screenshot, what you're seeing here is if you are missing, maybe you're referencing the main CSS file incorrectly, it can't access it, whatever it may be. Sometimes you'll get missing tiles, like what you see here, or, and I'll show you in just a moment. I'm going to go in and try something. So if I go into that index file, I'm going to change this and make it just a different name, one main. And let's go back in. I need to. Okay. Empty that. That looks awesome. There we go. All right, so we still have it. There's no empty tiles, but I don't know if you guys noticed this or not. I don't have the default zoom in or zoom out buttons. I don't have the attribution on the bottom right. And the reason for that is that all of that is built into the view CS, the CSS. So if it can't access it, it's not gonna know how to bring it on in. All right. Okay, so I got a lot of the overview fluff out of the way. So now we have our base map. We actually want to add some of your layers to it, right? So your base map's great and all, but you probably have some operational layers. You need to bring them on in and work with them within your map. We have various layer types that you can, various layer type classes that you can access within our API. This is just a little overview of them. If you go to our API reference overview, we have it broken down and we have our layers. In this particular example, we're working with a feature layer. So if I click on the feature layer, you'll see here the require statements, just all the stuff I mentioned earlier. You get your require statements, and then all the properties and methods and so forth. The main thing that I want to touch on here is when you're working with layers, it does not matter the layer type that you're working with. The steps that you use when you are implementing and bringing your layers into your application will remain the same no matter what. You need to load the module, so that require statement. So whether it's require Esri /layers/feature layer, Esri layers/layer/vector tile layer, whatever it is that you're working with, just reference that. Then you're going to create the actual layer. You know, set the properties of this layer. So however you want to, you know, if you want, you have some rendering, which we'll show you in a little bit, things like that. That's where you will set that. And then lastly, you're going to add that layer to either your map or to your scene. Okay, so no matter what, these steps will always remain the same. All right, I think you take over, right? Awesome.
Sounds good.
I'm going to let Noah talk now. I've been talking too much.
And one last thing I want to highlight, just in terms of terminology. So we have this idea in the ArcGIS ecosystem of maps and scenes. If you ever see the word map, you know it means 2D. If you ever see the word scene, it means 3D. So if you talk about a web map, that's a 2D. If it's a web scene, it's 3D. So that'll just help with future concepts. All right, so one concept that Heather touched on was properties. Now, there's two different ways that you can set properties with the 4.x API. One is the more old school way of getting and setting property values. That's using the object.property equal statement. Up here at this code snippet, I'm creating a new map, and I'm setting the map property to streets. Which I know is a string value because I see that in the API reference. Then I create a new view, which is a map view, and I assign a center and a zoom value to it. Another way you can define properties is actually in the constructor, and you'll know what properties you can set by looking at the API reference as well, but I know that the map view has a base map constructor, which is optional, but I can assign that to a streets value. Same thing with the map view and the constructor. I can set the map, I can define the center and the zoom. So if you're interested in this concept, we have another handy guide page that talks about how properties work in very readable English. Something you might want to do with properties is watch for them to change. So in the 3.x, we have this concept of event handling, which means that you wait for the user to do the thing, and then you do something else. So the example is you might want, when a user clicks on the map, might want to display a helpful pop-up. In the 3.x version, you were limited to whatever events we expose in the API. So if we expose click and double click, you can do click and double click events. At 4.x, we have this concept of watching, which means that if we have a property exposed, you can watch for changes to that. So up here, we're looking at a layer or watching for when the load status changes. Whenever the load status changes for this layer, we're going to fire off this unnamed function and pass in the actual status. So you can do that with any property that can be set in the API. And going along with that is a really nice sample called watch for property changes. So, and this is the sample code tab in the developer site where you can search for samples, or they're also organized by type over here. I'm going to come down here to view live. And so what we have is, it's a very basic web map, but on the right we have a separate div that's going to print out all these watch statements that we have in the code. So as I interact with the app, we're going to see some more statements get fired over here. This might not be your ultimate goal, but it's a nice proof of concept. So something that I do, something I did when I started, it's something I still do, is I come back to samples like this just to see how they handled, say, the view extent changing or the center changing, and see how they actually printed out that information to make it a bit interactive. All right, so now let's see another demo where we actually add this layer to the map. So this is the application. It's very similar to what we saw before. Heather showed you this lovely light gray base map centered around the United States, but now we actually have a layer on it. So this layer shows private school attendance in the United States, and now we're going to open up the developer tools and actually look at the source code. So the HTML file is exactly the same as what Heather showed before. We're not modifying that at all. We're only modifying the JavaScript. I'll make this a little bit bigger. So the first thing to look at is the modules. So Heather told you that the order matters. So we bring in the map module, the feature lay module, and the map view module, and we give them local argument names in that same order. And again, you get the module name from the API reference, or you can look at samples and just kind of cannibalize what modules they use and copy paste them. Then we have two feature layers. We have a point layer showing private schools. It takes one required parameter rather, which is a URL. I give it a URL to this long gnarly string, which is hosted in Portal. And then I have a polygon layer, which also just has a URL. So then I set up the map. I do var map equals new map. I'm actually using a vector light gray base map, and I pass in the constructor. And then in the new view, I pass in the container, this is the name of the div that I provide at the bottom. I tell it which map I'm actually looking at, a zoom, a center value, and then I have this statement. This is a view.when. So basically what I'm telling, because this is running asynchronously, I'm waiting for the view to be ready, and once the view is ready, then I'm gonna add the layer to it. You could also do a map.add, but this is kind of a cleaner way so that if you have some lag in the network, it's not gonna fire add the layer until the view is loaded. So that way you don't have multiple processes running and you can wait for things to be done in a more synchronous fashion, because really you wanna be able to see it before you add the layer to it. And then I'm simply gonna add just one layer, the polygon layer, to the map, and then I'm done. And so what I'm left with is this beautiful web application that I designed. Okay, but maybe we're not happy with how that map looked. Now, we saw a lot of really nice light blue polygons, but that doesn't tell a very compelling story. So what I want to do is I want to apply a renderer. So what a renderer is, it defines a set of symbols to be used in the layer. So this same concept applies in the desktop world with ArcMap or ArcGIS Pro, and it also applies in the web world. And if you're interested in renderers, once again, we have an awesome guide topic that gets really deep into visualization and the different types of renderers we have, and concepts like smart mapping and visual variables that are a bit beyond the scope of this presentation, but you can dig into the guide and you can read all about it to your heart's content. So there's a basic rule that you use with renderers, in that you apply a renderer to a layer, and then you're going to tell what symbology to use. But this is the very basic syntax here, where I have a renderer, and I'm going to make it of type new unique value renderer. And then I'm going to pass that renderer as a parameter to the feature layer. So this first line here defines which type of renderer I'm going to have. And then in the renderer property in the feature layer, I pass in that same renderer name. Now, right now it's not going to do much, but it is going to fulfill the basic minimum requirement of having a renderer. But you can see there's no code as far as symbology or colors or anything like that. So the next step is actually to apply a symbol. So you're going to have different symbols for different geometry types. So every different geometry type is going to need to have its own renderer. So you have three main types. You have points, lines, and polygons. So for example, for points, I can use the simple marker symbol, and that's just going to give it a very simple, unique PNG or JPEG file. And then I'm going to pass that in as the default symbol for the renderer. We're going to leave that alone for a minute, but we're going to get into why you have a default symbol a little bit later on. So those are the basic requirements for the renderers. You need to have some sort of symbology associated with it that's the same geometry type as your layer of interest. Okay, so another basic concept that's new at 4.x is this concept of autocasting. So you might have noticed in some of our code snippets, we don't have modules for everything that we're using. And that's because some modules can be autocast. What autocasting means is that you don't actually have to put it in the require statement. So some things like color, for example. If you want to make something blue, you don't have to require the Esri/color module. You can just declare it as a new color, and our API is smart enough to know where to find that module. Now, if you're doing a custom build, you're still going to want to have the color module in there because you still need it, but you don't have to require it. The nice thing about that is until you actually need that render or that color, it's not going to bother calling the API to bring that color module down, because every module that you require has to get downloaded by the application, and that again increases some size, increases some latency when you're waiting for the application to load. And of course, if you want to see more about autocasting, we have another awesome guide topic that talks about it. But at a high level, it just means you don't have to require it. You'll know that things can be autocast when you look in the API reference, and if you see this nice little tag that says autocast, then that tells you it can be autocast. And another nice example of that is in our sample code, we went to great lengths to comment every time a module is autocastable, we put that comment right in the code. So if you're looking for something that exists in the sample code, you're going to find out right away that something can be autocast and thus doesn't have to go in the require statement. Okay, so let's look at a cooler example that's showing something. So we have the same light gray base map. We have, looks like the same feature layer, although it's symbolized a bit differently, and we have these kind of really cool points in the middle of each state. So let's look at what we did there. So again, HTML file is exactly the same. We don't have to mess with that. The JavaScript file, we have the exact same 3 modules. So we haven't had to increase our modules because of autocasting. So the first thing we do is we create this default symbology. Now, I know what kind of symbol I want because I looked in the API reference and I looked at what should the default symbol be for a polygon layer, and the type is symbol fill. And I have this comment here that says, oh, it autocasts as new simple fill symbol. So you'll see that in the sample code as well. Then I give it an outline color, and this color autocasts. I give it a hexadecimal value, and I give it a width. Now we're going to create our renderer. So the type of renderer is simple. We have many different renderers that you can see in the API reference, but this, for our basic example, we're going to use a simple renderer. For symbol, we're going to define the default symbol. So this means that later on, when I define the visual variables, any data that doesn't fall into those visual variable categories will get a default symbology. So it's nice to have in case you have data that maybe doesn't fit your expectations or that you don't know about. You have a catch-all category that can still symbolize it, so at least you see it on the map. So I'm going to give it a label, and I'm going to use this concept of visual variables. What visual variables allows you to do is to create a continuous ramp of either color or size for your information. So you see here that I'm not actually setting specific values to colors, or I'm setting specific values to colors, but I can set different values and have different labels for each color. So at the lowest level, I'm going to have this, which is going to equate to more of a light blue color. And at the highest level, I'm going to have this color, which equates to a dark purple. Now, for the color variable, you can pass in actual strings. I could say blue or purple. You can use hexadecimal values, and you can use RBG values. So you have 3 different ways you can set color. Okay, so I have that render, and that was for the polygons. Now I'm going to create a renderer for the points. So I'm going to use, again, a simple renderer. I'm going to have the symbology here, and the type's going to be picture marker. What this means is that I want to actually call a URL, and this could be a local file or it could be on the internet, to actually get this PNG file to symbolize the points with. So I give it the URL, and then I assign it the width and the height. That makes sense, and that's going to be the renderer for my points layer. So now I'm going to create the feature layers just like I did before, except in the constructor, I have an additional property called renderer. So this is the points layer, and again, new feature layer, and this is the URL. And then for the renderer, I pass in the centroid renderer, which is my point renderer. Polygon layer, much the same, create a new feature layer, define the URL. I'm going to pass in that renderer. Now I'm going to do 2 other things here. One is I'm going to set the opacity, which means like opacity is basically the opposite of transparency. So 0.08 means that it'll be 80% visible or 20% transparent. And I'm going to set something called outfields, which we're going to see in a later example, but I'm going to use this wildcard character to indicate I want every possible outfield of the feature layer, which means all the data that's actually associated with each feature. Then the map constructor is the same as it was before. Same map view statement, and instead of a map.add, because I'm going to add more than just the polygon layer, I'm going to do map.addMany, and I'm going to add the polygon layer and the point layer, and it gets passed an array. So, and I know this because if I go to the documentation for map, I'll see the available methods, and I'll see this addMany method, which takes in an array, whereas the add method just takes in a singular object. And what I'm left with is kind of a useful map. Now, you might not know what's going on here still, but at least we've shown that you can take a base map, add a layer, and then actually make it look like something that you like. Yes, sir. Oh, sure. So the question is, the gentleman wants to see the actual URLs where the layers are coming from. Maybe he doesn't believe that they exist, but I'm just kidding. Sure. And we'll have time at the end also to handle questions, and we'll be at the island if you have any follow-up. So this is the URL that I pass in for one of the feature layers. So I'm going to go to what's called a REST endpoint. So here I have all the information about the layer. So for example, if you've been given an application that you need to work on and you're trying to figure out what's broken, best place to start is to start from REST. So we used to have a saying when I worked in technical support that Jared could verify that if it doesn't work from REST, it's never going to work, which means that when you publish the application and you access it from the REST endpoint, that's the most basic model of the data that you can consume. So it doesn't matter how good your code is, if it doesn't work from REST, it's never going to work. So these are all the fields that got published with my data, and then it tells you which type each field is, and sometimes they have a little description that helps you understand it. Oh, the default?
They have the feature layer, the render. Yeah. application.
Let's see it.
Yeah, and that gets saved and brought over too.
Oh, okay, here. So in this property and drawing info, this is the default renderer. So when you publish it, you typically have some sort of visualization associated with, if you're publishing it from Pro or from ArcMap. And so if I don't apply a renderer, this is the default rendering that will be applied to it. Maybe we'll save that for afterwards. We don't want to get too bogged down now. But there's a couple other things that's cool to look at from REST. But suffice to say that you should inspect your services and your layers from REST and kind of take a look at what's there and their spatial reference and what kind of rendering they already have and their extent and all those sorts of things. Yeah, cool. Good questions though. Okay, with that, I'm going to turn it over to Heather and we're going to add some interactivity.
Awesome, thank you. So Noah basically just, segued into it saying we have a nice looking map now, but it doesn't really tell us a whole lot, right? So one of the main things that you're probably going to want to need or want within your application is some map interaction. One of the most basic ways of doing that is through pop-ups. So basically all a pop-up is it's just that. It listens to your mouse clicks. So you click on a specific feature within your map, and a pop-up will display then based upon however you have it configured, showing whatever it is that you want to have, whatever it is that you need to have displayed within that pop-up. So it can give you information on feature attributes. It can give you information on the location that you clicked on. You can even configure your pop-up for when you have, like within your search widget, your search results. A pop-up can be configured for however your search is in that case. So it is fully customizable, and I'm going to show you exactly how to do that. First things to go over though is that the view, the scene view or the map view, they have an associated pop-up property that goes along with it, and you can set content within that property. The feature layer has an associated pop-up template property, and that works with like your attributes and so forth, and we're going to show that within this demo. We also have the ability to position your pop-up using dock options. So let's actually just take a look. It makes it a little bit easier, I think. Okay. So we have our application here, and last I remember when the data was made, or when I put all of this together, Pennsylvania at the time, did we tell them what the data was supposed to be representing?
I mentioned
public versus private schools. Okay, so what we have here is, I'm going to go ahead and click on the state of Pennsylvania, and at the time, I don't know if it's still the case, but I think they had the highest concentration of private schools at that time. And the way that I set up my pop-up was I configured it to show specific fields that I have within my attribute table. So I've got like the state name, majority grade level, total number of students, and so forth. But I also have it configured to work with some media. There's two different types of media that you can show within your pop-up. You have charts and you can show images. In this particular case, I'm showing two types of charts. I've got a pie chart and I've got a bar chart. So let me go back a little bit. If we take a look at the pop-up template class, the pop-up template class, and you'll notice here just, if you take a look at the scroll bar, it's pretty small, so you see there's a lot to it. We have a content property within this class. This content property can take in a content element, an array of content elements, string, function, or promise. In our particular example, we're working with the content element. There's 4 different types of content elements. We can work with text, we can work with media, and like I said before, the media can be a chart or an image. We can work with fields, so the fields within your attributes of that feature layer. You can also show attachments as well. So if you have attachments associated with that feature layer, it will automatically recognize that if you set that attachments content element within the pop-up templates content. So let's take a look at the actual code. All right. All right, so what we have here is I've created an instance of a pop-up template. I'm passing in a title, and this is really what I want to take note of, is the content. I'm passing in an array of field info objects. Okay, the field info objects. Remember what Noah was talking about, if it was autocastable or not? Well, field infos, this is autocast. This is being autocasted to a field info object. Okay, we could break it out. I could create individual, whatever, var field info 1 equal new field info and pass in state name, true, state name. I could do it that way. Or I could just set it this way and just automatically just nest it within the content property of this pop-up template. So I have an array of field info. I'm passing in the field name, and this is the field name that's set within the actual data, okay? Whether or not I want it to be true and how I actually want that field to be displayed. Okay, so I have it set for a few different fields in here. This one is a number field, so I'm also setting how I want this number to be formatted. Okay, so these are all of the fields. I've got quite a few. I think there's like 6 or 7 in here. And then next, what I have is I've got my media type. All right, so you have to specify the type that you're working with, whether it's text, fields, media, or attachments. So I've got my fields that I did earlier. Now I have the media. So a media info, just like the field info, the media info is also being autocasted. So I'm telling it the title, I'm telling it the type. So in this case, I'm working with a pie chart. It could be an image, it could be a line chart, it could be is it a column chart? There's a few of them. And then the caption that I'm working with, the values that I want this, the chart to represent, so the values within my fields. So I want it to show the private enrollment and the public enrollment. And then basically just showing the same exact thing using a bar chart. Okay, so as you guys can see here, I get a little bit more information now, right? And I also, if I wanted to, you can go ahead and you can work with, you can create a function, and based upon what that function returns, you can pass that in as your content. You can work with promises. Once your promise is resolved, you can take that, pass that in as your content. You can have your own custom markup. You can bring that on in. There's a lot of different things that you can do within here. There's going to be, if anybody's interested, there will be a demo workshop. I believe it's Thursday on customizing this type of stuff. So we're kind of doing very high level, but it's just a lot of really cool, useful information and a lot of cool things that you can do with it. Alrighty, let's see. Any more? No, I think so. You got it.
Okay, so everything that we've just shown you is kind of a lot. So we've looked at layers, we've looked at map views, we've looked at symbology, we've looked at renders, and now we've looked at pop-ups. So we showed you a lot of different modules, a lot of code that does a lot of really awesome things. But there is another way, and you'll really appreciate this other way once you've gone through all those steps. And the other way is called a web map, or if you're working in 3D, it's called a web scene. The code isn't quite as long. This is basically the constructor for making a new web map. I assign it a portal item, and I'm done. And if you don't believe me, we can actually look at a live demonstration of what this finished product looks like. So you'll see it looks very similar to the same map that we showed you before. We have the same map, we have the same layers, we have the same renderer, and we also have the same pop-ups. So you can do everything that you could do before, but when we actually investigate the code here, we have 2 modules, a web map and a map view, and then we pass in the portal item to our web map, and we add the map to the view, and we're done. So what we did behind the scenes is we went into ArcGIS Online, and you can also use Portal for ArcGIS, and we brought in the data, and we symbolized it using a renderer, and we added the pop-up the same way we did as a code, and then we saved it. When we saved it, we got this long, gnarly string, and all we had to do then was consume the string, and suddenly we have this full functional application that we technically wrote some code for, but we didn't have to spend all our time figuring out how to do the rendering and the exact color that we wanted. We could actually use a GUI to do, or a graphical interface to do all those things. So while we love the API and we love coding, if you can save time doing this, we highly recommend you can just do it in ArcGIS Online, and then you can consume the same web map in a variety of different applications that you can still style differently with the CSS. You can add different widgets that we'll see later. But this is a great time-saving device, and it's also a really easy way to get started with programming with the JavaScript API. So I've said my piece. I'm going to turn it back to Heather, and she's going to take it home.
Great. Okay. Am I on? Yeah. Okay, so lastly, we've got widgets. So basically all a widget is, it's just like it says, it encapsulates functionality. So specific functionality that you want to have within your application, wraps all that up and makes it within what we call a widget. One thing, just like we have with the layers, remember I said we have a similar coding pattern, regardless of the layer that you're working with. You require your layer, you instantiate the layer, you set the properties, you add your layer. Same exact concepts go for the widget. Depending upon, or it doesn't depend, I should say it doesn't depend on the widget. Doesn't matter what you're working with, the steps that you take when you're bringing your widget in will always remain the same. So let's go ahead and take a quick look here. And I'm not gonna get ahead of myself. I just wanna show you the demo first. All right, so this is what we're looking at. We've got two separate widgets in this one. We've got our legend widget, and we have our measurement widget. This does just basic distance, just from one A to B, and this does the area. So, you know, like a polygon. You're trying to create your, you're measuring your area. So how do we actually bring this in? Well, actually, let's take a look and see how it works first. So go in here, and zoom in. Let's go in. Just go to Atlanta or I should say the centroid of Georgia to the centroid of North Carolina. And I don't know if you guys can see that or not. It's showing me 511 kilometers. Okay. And if I go in here, I should be able to do the same exact thing with area and perimeter. All right, so if we actually take a look and see what we have within our code, you'll notice here, and I'm just using the web map to make things simpler. You'll notice here, I am creating a new legend. So at the top, I require that Esri widgets legend. I'm grabbing the layer info off of the web map. So I'm passing that in to the legend. And then what we have here is off the view, we have this UI property where you can go, the view UI. You can add, you can remove, you can move different elements. So in this case, I'm adding in that legend and I'm telling it, hey, I want this legend to be situated in the bottom left corner of my application. I'm doing the same exact thing here as well with this element called the top bar. So if we take a look here and we see, where is the top bar? Oh, it's in the HTML. Let's take a look. So if we take a look at the actual markup here, you'll see I have a div ID called top bar. All right, and within this ID, or within this div, that's where I'm holding on, or I have the distance and the area measurements. So if we take a look at that JavaScript, we'll notice here we have the get element by ID, the distance button, we're setting an event listener on it, and passing in the active widget, and we're checking to see, hey, are we working with distance or are we working with area? If we're working with distance, we're setting the active widget to the distance measurement 2D, or if we're working with area, we are setting that widget to the area measurement 2D. So I'm not going to go into detail with step-by-step of this, but just the main things that I want you to remember from all of this, again, is that it doesn't matter what widget it is that you're working with. We've got lots. We've got the directions widget. We have the search widget. We've got the locate widget. Lots. It doesn't matter as long as you follow the same steps. So you need to make sure that you require it. You create a new instance of it, like in this case with the legend. We set the properties, and then we add that to our view UI. So the top bar that holds onto that measurement, that's going to be in the top right corner. All right. So one thing else I want to show here, kind of briefly for the sake of time. So you'll see all of those underneath the Esri widgets namespace, and you can see here that they just keep adding up. So we've got our area measurement 2D, area measurement 3D.
Quick question. When are custom styles added to the measurements and drop-down?
I'll take that at the end, if you don't mind. We're almost finished. We need to wrap up with time here. Okay, so you can see here we've got, there's quite a few, okay? All right. And like I mentioned earlier, we have the view UI, so you can position those widgets with the add, move, or remove. All right, so we kind of just threw a whole lot of information at you guys. We know it is an intro session, so we don't expect you guys to be able, well, you may or may not remember all of this, but we have all the sessions, everything that you see here, the presentation, the slides, the demos, all of them are on our GitHub repo, or my GitHub repo, so you should be able to access that. Take that later on if you want to play around with things, go in there, start deconstructing some of the code. The main thing, though, is just really get familiarized with our SDK documentation. That's probably the biggest thing out of all of this, if you can take away from this, is just get familiarized. Know, bookmark it, know where things are located in the API reference, the guide topics, samples. We're continuously trying to improve it as well, so we're always taking feedback on what can be added, improved on. We have Esri related training, so if you guys are wanting to go in and sign up for some webinars, there's free stuff, not so free stuff. You can always find information there on our website. Just straight JavaScript training, so for those of you just coming in, out of fresh and haven't worked with this before, again, free and not so free. And I can't stress how beneficial the GeoNet site is. I still find answers there, like people are like, maybe you find a bug, or just, hey, had someone tried to do this before? I see this as something new. And, we'll go in there to see what other people are trying to do with the API and the software as well. And we find a lot of really good information. So if you want to be a superstar, get some MVP credits, go ahead and get in there and, start answering some questions. Stack Exchange, Spatial Community and Slack, I'm in there as well. Noah, I believe he is too. We have some additional sessions here, so lucky you guys, this is in the beginning. So we're here for the rest of the week until Friday. We've got a bunch of new sessions coming in. If you guys are interested in 3D, bunch of stuff, rendering. TypeScript, I think there's an intro session, I believe, right after this. So for those of you who might be interested in working in TypeScript and just using that with our API, it's awesome. I'm a firm believer in it now, Convert, so if you guys like that, that's a good one to go check out. And we got our visualization ones. And lastly, please take our survey. We can only improve. Again, we know it's a lot of information to take in, and it's right after lunch, so hopefully it wasn't too much. But yeah, take the survey, and we thank you. And questions, we have a little bit of time, or you can come on up here if you're too shy. I know you had something about the styling, but any other questions as well, we can handle that. So I just want to start closing down because I think we're going to have someone else coming in too. So